So our company has a mission and a vision, and it's ambitious. We're going to revolutionize nickel production. We're going to disrupt contemporary carbon storage, and we're perfecting the dream of zero carbon motoring. The chemistry of our team is such that, well, I started it with mineral exploration and came across olivine and have become a little bit of, let's say, a guru in the olivine world. But in that, I needed help. And I got to know a man called Bill O'Connor, who ran the US Department of Energy program for carbon capture using reactors between 1999 and 2005. And they closed down the program because it was too expensive, $54 a ton of carbon at the time. But Bill is coming and giving us great advice on that. But we've also got to know Fei Wang, who's an expert in the precipitation of nickel from olivine. So we're joining two things here, nickel production and carbon sequestration. Igor, who's our chairman, has experience in greenhouse gases as an expert in that since 1999. He's a mining engineer and has a lot of experience in chemistry. So he's leading our strategy in the company. Taj is an experienced financial with VC and PE, but has also managed a reactor production manufacturing company for 10 years in the early part of this century. And Dennis is our environmental and sustainability guy. Now, the problem that we're looking at is nickel. So nickel has two issues. One, there's not that much of it actually being produced, 2.5 million tons a year. But the bigger problem is every ton of nickel produced releases or emits 20 to 60 tons of carbon dioxide. In the European Union, under CBAM, the Carbon Border Mechanism, it's coming into play. All nickel being imported, and remember, nearly all nickel used in Europe is imported, is going to be heavily taxed with carbon taxes. The second thing is that the European EV policy is no petrol or diesel vehicles on the road after 2035. At the moment, there's 75,000 tons of nickel just required for that purpose. And what we're going to see is that by 2040, we're looking at nearly 625,000 tons requirement for the EV market in Europe. But world demand is going to be 6.2 million tons of nickel. So it's quite a jump over 15 years, 3 times more. And the biggest problem is that all the nickel produced is not going to be able to compete with our nickel, which is going to have a negative balance of 215 tons of CO2. This means that we can do something fantastic. We can produce 1 ton of nickel that gives green batteries or the green nickel to the batteries for 20 vehicles. At the same time, we're creating a negative balance of 215 tons of CO2 per each ton of nickel. And we can then offset the manufacturing scope 1, 2, and 3 of the of the 20 EV vehicles, and also offset up to 60,000 kilometers for 20 EVs that would be running on, let's say, electricity that's got CO2 emissions, such as in the UK. How do we do this? Well, our secret is we're extracting the nickel by sequestrating CO2 in olivine. So again, for every ton of nickel, olivine, well, sorry, if we go back, say olivine, it's a magnesium-rich rock containing nickel in its matrix. And it's broken down by pressure, temperature, and CO2. The magnesium in the olivine absorbs the CO2 and the nickel gets liberated. So we have a simple solution for, let's say, a big dilemma in the steel and battery manufacturers. We're disrupting the storage of carbon world because we're saying don't waste it, don't pump it into the ground and store it there, but let's put it in a reactor together with olivine, and that will lead to not only the production of nickel, but also the production of magnesite, which is the magnesium and the CO2 being bound together in a mineral form. Our business has diverse revenue streams. So we're looking obviously at the green metals, the nickel and also silica, and also the selling of carbon credits, which allows us to forecast at the moment about 14,000 tons, 14,000 euros per ton of nickel that's produced. In this, our profit and purpose are very much aligned. We're certainly building momentum, and over the last 3 months with Carbon 13, we've advanced to NDAs and MOUs with both suppliers of the raw materials that we need, which is the carbon dioxide and olivine, but also with the end users or the trading companies that will require both nickel and silica and CO2. So the need is clear, the market is ready, and we would like you to be part of this momentum as well. And why would you like to be? Because we've got very, very admirable advantages over our competitors. First of all, we're looking again at two markets, the nickel and the carbon. Uh, our nickel advantages are that our nickel is all green. We can produce in the UK and EU, and we can offset CO2 emissions to Scope 3. We're competing with traditional mining and scrap, all which have their emissions. The second is in the carbon storage. We're competing probably realistically with the oil and gas reservoirs, like Acorn and so forth. A little bit with enhanced weathering and oceanic CCS. But our MRV is a AAA. It's based upon actual physical sampling and analysis, chemical analysis of residue. Our permanence is geological, hundreds of thousands of years because we're creating a new rock. And our reaction happens in a few hours. And above all, we're geographically flexible. We can go to where the carbon is. Our market, well, in our SOM, we're looking at the EU and UK batteries. And by 2035, we plan to produce 40,000 tons of nickel, which is nearly 11, which equivalates to also nearly 11 million tons of negative CO2. Um, Going forward, we're looking at the EU, UK batteries and steel market, which is a 1.6 million ton requirement for nickel and also a requirement for nearly 434 million tons of CO2. The global, we can certainly go to wherever carbon dioxide is, and nickel requirement is not just in Europe and the UK, it's certainly big in the US and in China and Japan. Our carbon case is again extremely impressive. Even just looking at this graph, you can see the two first lines. The first is the summary or the net. The second is how 271 tons of nickel is what we're sequestrating. Our own process, of course, has its own emissions related to the mining of olivine, shipping, and depending on countries, the energy that's required for our process. We've calculated 54 tons per ton of nickel. But at the same time, we're avoiding another 20 tons of nickel, which is the traditional mining legacy. As we move forward, we have again further potential because we can manage the upstream by reducing our carbon emissions in both mining and in transport, and we're looking at reducing that by a further 10 tons. And by using renewable energy, we should be able to save another 23 tons of carbon dioxide per ton of nickel. We have a non-paralleled carbon negative footprint, and there's still room for improvement. On our CCS qualities, we certainly are in a particular place because our additionality is very significant. We have no carbon leakage. The permanence that we're looking at is hundreds of thousands of years, highly efficient carbonation in a few hours, and our MRV is out of this world, to be honest, when one is looking at the carbon markets. And environmental is low risk because we're using minerals that are safe for human contact, both olivine and magnesite. On our freedom to operate, we're basically looking at two sides. One is IP development. So we expect in 2025 and 26 to already start registering patents. The first is on a helix-based sequestration reactor, which will be unique in the reactor world, but exactly what we need and is, let's say, very simple and straightforward from a technical point of view. The second IP will be on amorphous silica recovery, which is basically the olivine breaks down into silica and magnesite, after the nickel is precipitated out, and that silica recovery can also become a very high revenue stream for us. We expect to design a very special flow sheet on that. We're also looking at joint IP on the nickel precipitation with Fei Wang and his colleagues. On our, again, freedom to operate, our raw material supply is we've secured Olivine's supply line, and we've got a very clear strategy of using existing patents on we've accessed the existing patents on reactors which other companies are developing, and we don't see any conflict for our own reactor design using CO2 sequestration and olivine processing as the means. Um, Here again is a summary of what I've just said. To put it more in context, the most important thing I think here is that the nickel precipitation is covered by an IP from the University of British Columbia, owned by licensed to a company called Lead FX, and we're in, let's say, serious uh, negotiations with Lead FX at the moment. We have an NDA in place outlining our process, and we're looking at joint business opportunities. We see huge potential for us in this because their interest is not olivine. Their interest is in developing their IP further and optimizing it for laterite nickels. And that's where we can see a scratch my back, scratch your back scenario. And there's no patents on the amorphous silica. So we expect that to be very important groundwork that we're building upon. Um, our targets over the next 10 years is by 2035 to be producing 40,000 tons of nickel, which is equivalent to 10.8 million tons of CO2. Uh, and again, our market is the global batteries and steel markets. We would expect to be hitting commercialization in 2028, going into 2029. Um, and we're expecting, at least at the pre-seed, to be looking for £900,000. That will bring us to finish at least the TRL level 6 stage. Um, sorry, so the 900,000 these are the reasons for raising that amount of money. The next steps will be laboratory work with Fei Wang on the nickel precipitation optimization and the design of the amorphous silica flow sheet design, and therefore our IP, registering those patents, optimizing the process of, again, carbon sequestration. If we can speed it up, it means we get more done per reactor batch. We're going to be designing and engineering the reactors and registering the equivalent IP. We need to develop the markets, and we need to expand our team. At the moment, the team is the four of us. We've all coming from various sectors, from both the financial world to the mineral world to the environmental world. And to finish, Paul suggested I finish, for people who don't like poems, with a limerick. With Olivine's help, CO2 we snare, while nickel emerges with care. We capture and bind a solution refined for a future both precious and rare. Thank you very much, and we hope that you will help us transform the future.